Hello students. So we are discussing KVPY 2020 essay paper part 1 of physics. We are now discussing question number 25, which is the 10th question of part 1. So let's have a look at this question. This question says that at a height of 10 kilometer above the surface of the earth, the value of acceleration due to gravity is same as that of particular depth below the surface of the earth. Okay, now to answer this question, we must be aware of the formula of acceleration due to gravity at a height h above the surface of the earth and at a depth d below the surface of the earth. Okay, now the value of gravity at a height h above the surface of the earth is given by gs into 1 minus 2h divided by r, but this formula is applicable when h is much less than the radius of earth, which is presently the case. We are talking about a point which is at a height of 10 kilometer above the surface of the earth. So 10 seems pretty small as compared to the radius of earth, which is approximately 6,400 kilometers. Okay, so that means we can use this formula. And the value of g at a depth d is given by gs into 1 minus d by r. Okay, now, and this formula is applicable for any value of d. It doesn't have any conditions such as d should be very small as compared to r. So this formula is valid unconditionally, assuming that earth is a round sphere, like it's completely spherical in shape and it has a uniform density. So in the present question, we have been told that these two values are equal, and when we have a look at this formula, it becomes obvious. You can do it mathematically also, but I think it's pretty obvious that d should become equal to 2h, which basically means that the value of d should be 2 times of h, which is 20 kilometers. So option D should be the correct answer, and if we check the correct answer, it is option D. So it was a very simple question. If you knew the formula for value of gravity at a height h also and at a depth d also, and if you were not aware of these expressions, then this question would have consumed a lot of time in the exam, and the right thing to do would be to leave the question if you are not aware of the formula. And if you are aware of the formula, the question is pretty easy. I'm assuming most of the students who were aware of the formula would be able to do this question in the actual exam. With that, I'm ending this solution. I'll see you in the next one. Take care, guys.